All right, so here's example 3. So it says, what are the measures of angle R and angle S in triangle RST? And again, we're actually going to solve this triangle. So again, solve the triangle. All right, so if you look at this picture, right, this is your side-side angle case. And I'm actually going to change the directions up again, and you'll see there's a second slide identical to this in your notes. You're going to see we're going to do this problem twice, actually. But neither here nor there. Let's focus on finding these angle measures. So in this picture here, right, there is one and only one thing you can find right now. And the one and only one thing you can find right now is angle S. This must be found first. And the reason is you have your T's, right? This is lowercase t. And you have side S, right? You know nothing about the R's, so you can't even touch the R's. So you have to find angle S first. And to do that, we're going to use the law of sines. So we're going to do sine of S over S equals sine of T over T, right? We don't know what S is, angle S. We know side S is 12.7. We know that angle T is 74, not 47, 74 degrees, sorry. And then side T is 12.3. So we're going to cross multiply. So 12.3 sine of S equals 12.7 sine of 74. We're going to divide by 12.3 to get sine of S equals 12.7 sine of 74 divided by 12.3. And now what we have to do is to release the S from the sine, we have to do the inverse sine. So I'm going to come up here. So to find the measure of angle S, we're going to take the inverse sine of this whole big thing. Now, if you want to type this in first and then take the inverse sine of that number, that's fine. Just make sure you don't round too much. And you can actually use the answer button or the copy button. So I'm actually going to show you that, okay? In Desmos, you're just going to copy and paste or just retype it out. But in a calculator, usually there is a second key, right? So to get this answer, second key and minus above the minus sign on a graphing calculator. So that's on my dinky calculator. On a graphing calculator, it's also above the minus sign. It says A and S. And that's a way to stick the previous answer into the problem. But on Desmos, you're going to type it out. Okay? And this will give us the measure of angle S in degrees as long as we're in degree mode. Okay. So I'm going to get rid of this. This will help us find angle S. 12.7 sine of 74 divided by 12.3 in the inverse sine. Now, there's nothing stopping you from doing inverse sine right now, but I just think it's messy. So 12.3, let me do the fraction first. So fraction 12.3 sine of 74 divided by 12.7. Again, sorry, numbers, they're so close. 12.7 sine of 74 divided by 12.3. And again, that's not the answer. So then we're going to put that in the inverse sine. So inverse sine, remember sine -1 of that. 0.9925238. And you can see it's not changing much, right? It's going to round to 83, right? So this is 82.9, which is 83. So if we go back to our notes here, we just got that the measure of angle S is 83 degrees. Okay? And now we can use the R, we can use the angles to find angle R. So we know that the three angles add up to 180. So 83 plus 74 is 157, sorry. 157. Subtract that from 180, 180 minus 157, and that is 23 degrees. So now we have all three angles. Again, using their capital letters on Savas, so angle R is 23 degrees, angle S is 83 degrees, and angle T is 74 degrees. So we got the three angles. So now the last thing to find is side R, right? So now we're going to use the R's, and I'm going to use the T's because, again, we had to round to find S. So sine of R over R is equal to sine of T over T, lowercase t. So that's sine of, and I just found R was 23, sine of 23 over R equals sine of 74 over 12.3. I'm going to cross multiply. So R sine of 74 equals 12.3 sine of 23. And then I'll divide by the sine of 74. And this is what I'll type in to get r. And notice I don't need to find or use the inverse sine because I'm not finding an angle measure, I'm finding a side length. So 12.3 sine of 23 divided by sine of 74. Again, I'm in degree mode. So fraction 12.3 sine of 23 divided by the sine of 74. And that's 4.99, which rounds to 5. So if I go back to my problem here, so this triangle, I knew the angles. So R was 23, S was 83, T was 74. Lowercase r is 5.0 feet, S is 12.7 feet, and T is 12.3 feet. And notice, the angles, the ones that are closer together have side lengths that are closer in measure. So now you will see something like this. It'll see, okay, so that was using S as acute. And again, I have another slide for you. I'm just going to do it on this slide. That is if S was acute. Now it's going to say, all right, part 2. So what if angle S is obtuse? And you're like, well, what do you mean? It's 83 degrees. That's not. Well, watch this, right? If I had a compass and I measured this distance and I put my point on R and I swung this around, it would swing like this and it would actually come back here. And there's actually a second triangle right here that can be formed. It's really skinny sliver, all right? But it looks like this. With R here, T here, the 12.7 here, but now the 12.3 swung here, and this I'm going to call as S prime. And now S is an obtuse angle. There is a second triangle we can use, all right, because the given situation was side-side angle. If you remember, in triangle congruence, we said you cannot use side-side angle to prove triangle is congruent because of this situation, that you can have multiple triangles from a given side-side angle situation. So we're going to find the next set of stuff, right? T is still 74 degrees, but now we'll have angle S prime, angle R prime, and side R prime, right? The second set. So because S was 83 degrees, that's acute, we're just going to find S prime, angle S prime, by taking 180 minus 83. And that's 97. So now, what if angle S is 97 degrees? Well, we're going to find R prime the exact same way. We're going to add up 74. So to find R prime, we're going to add up 74 plus 97. And that is going to be 171, and then subtract that from 180. And that's 9. So now angle R prime, and you can see, is a skinny 9 degrees. So there's R prime, and there's S prime. And now we're going to find side R the exact same way. So we're going to use R primes. So sine of R prime over R prime, and we're going to use the T's, equals sine of T over T, right? Sine of 9 degrees over R prime equals sine of 74 degrees over 12.3. We're going to cross multiply. I'll do it up here. So R prime sine of 74 equals 12.3 sine of 9, and divide by the sine of 74. And we get R prime is 12.3 sine of 9 degrees over sine of 74. And we're going to type that into Desmos and get an answer. And it's going to be shorter than 5 because, again, the triangle is different looking. 12.3 sine of 9 over sine of 74. And you'll see that when I go there, I already have that in the calculator. 12.3 sine of 9, just change that to a 9. And you can see now that your length of R prime, one sec, that your length of R prime is now, sorry, buttons. That your length of R prime is now 2.0 feet. And that's a whole second set of triangle features. So if I go back, right, if I can remember, so for the second triangle, right, R prime was now 9 degrees. S prime was now 97 degrees, and T was still 74 degrees. It didn't change. R prime was now 2.0 feet. S was still 12.7 feet. It's still the longest side. And T is still 12.3. And there you go. So that side angle case, be careful on your practice. Okay? All right, and then last but not least, back to normalcy, number 4. So it says the map shows the path a pilot flew between Omaha and Chicago in order to avoid a thunderstorm. How much longer is this route than the direct route? So this would be the direct route right here, this 471. Right? So our job is to find these two lengths. I'm going to call this one X. I'm going to call this one Y, right? So we need to find those. I actually, what I did was actually used, hold on, I'm not going to use those letters. I actually used the letters of the cities. So I let that be O, I let that be T, capital T, and I let that be C. The O might be a little bit much, but that's what I'm doing. Okay? So then we need to find lowercase o and lowercase c, add them, and compare to 471. How much bigger is 471? All right, what do they give us? This is angle side case. So we can get right to work finding a side length. I have to use my t's because I know both of them. So then let's use c, angle c, and find side c first. So sine of c over c equals sine of t over t. Sine of 22 degrees over c equals sine of 113 degrees over 471. We're going to cross multiply c sine of 113 equals 471 sine of 22 degrees, and then divide by the sine of 113 degrees. Type that in Desmos and we'll get an answer for C. Let's round to the nearest tenth, unless it's nice to not. So 471 sine of 22 over sine of 113. Fraction 471 sine of 22 over the sine of 113. And there I got 191.67. I'll go 191.7. Okay, there we go. So that's going to be the length of C, 191.7. And that'd be miles, I assume? Yeah. All right, so I'm going to clear that, go back to the problem in here. And again, we're going to call this 191.7 miles. And now we need to find lowercase o. We can find angle O by taking 113 plus 22 to get 135 and subtracting that from 180 to get 45 degrees. So I know that the measure of angle O is 45 degrees. So now we use the O's, and again I'll use the T's because again I had to round to find this length of C. So sine of O over O equals sine of T over T. Sine of 45 degrees over O equals sine of 113 degrees over 471. Cross multiply O sine of 113 degrees equals 471 sine of 45. Divide by the sine of 113. And again, all you have to change is that it was a 22, now it's a 45, right? 471 sine of 45 over sine of 113. And there I got 361.8. 361.8. So here in the picture, one second. So I know that this was 191.7. I knew that this was 361.8. So I'm going to add those together. So 191.7 plus 361.8, that equals 500. 553.5. So 553.5, and then I'll subtract 471 from that. So 553.5 minus 471, and I get roughly what? 82.5 miles. And that's how much further the roundabout way was than the direct route. Good, so hopefully you found this interesting. Again, it's a lot of good problem solving based off formulas, so I think you should be good at it and handle it okay. If you have any questions, always just ask. All right, thanks for watching.